At its peak, a factory on Beaver Street in Lincoln employed 3,000 workers across 30 bays, half a mile of frontage, building the largest excavators in the world. A sign over Lincoln's High Street said so, and the order book confirmed it. Cable-operated shovels and walking draglines that dug the coal, shifted the overburden, and reshaped the surface of post-war Britain from Northumberland to South Wales. Then the world moved to hydraulics, and Lincoln chose cable. A conglomerate parent that hoarded cash instead of investing it. An American partner that pulled out and sold the heritage for £4 million. A Goldman Sachs leveraged buyout that destroyed what was left of the lifeline. By January 2001, 30 employees built the last crane on Beaver Street, and a gate that had opened for 70 years swung shut on a winter Friday. Today, a Morrison's and a B&Q stand, where the erecting shop rose 80 feet to its roof trusses. This is the story of Joseph Ruston, a cutler's apprentice from a Cambridgeshire fen, and the 70-year factory whose machines dug the modern world. Not through one catastrophe. Through a cable bet held too long, two parent companies pulling in opposite directions, and a town that lost its giant so slowly, the moment it ended was almost private. Chapter 1. The Cutler's Apprentice. The story begins not in Lincoln, but in a Cambridgeshire fen town, and not with engines or excavators, but with cutlery. Joseph Ruston was born on 12th February 1835 at Chatteris in the Isle of Ely, flat, waterlogged country where drainage was life and the failure of drainage was ruin. He was the youngest son of Robert Ruston, a nonconformist farmer whose Methodist faith shaped the household as firmly as the fenland shaped the fields around it. The family weren't poor, but they weren't gentry either. They sat in that particular stratum of provincial English life, where chapel attendance, hard work, and a deep suspicion of inherited privilege formed a single moral architecture. Joseph grew up inside it. He was sent to Wesley College in Sheffield, a Methodist institution, a deliberate choice, and from there apprenticed at George Wolstenholme and Son, the celebrated cutlery makers whose I times XL trademark was recognized from Calcutta to California. Wolstenholme's was one of Sheffield's aristocrats of steel. The apprenticeship taught Ruston metalwork, certainly, but it taught him something more valuable: how a manufacturing firm of ambition organized itself, how it sold to the world, and how a reputation for quality stamped into every blade could open doors that money alone could not. He was 21 when his father died and a modest inheritance came through. Not a fortune. Enough. And what Joseph Ruston did with it tells you everything about the man. He didn't stay in Sheffield, where the cutlery trade was established, competitive, and crowded with men who'd been at it longer. He looked east to a city he'd likely visited through trade connections. Lincoln, a cathedral town on the edge of the largest arable region in England, where the mechanization of farming was creating a hunger for portable steam engines that the existing workshops couldn't satisfy. In 1856, aged 21, Ruston used his inheritance to buy a partnership in a struggling millwrights called Burton and Proctor, founded in 1840 on Waterside South by Theophilus Burton and James Toyne Proctor. The firm made agricultural implements. It was small, perhaps a dozen men, and it was going nowhere in particular. The Morning Chronicle of August 8, 1857, recorded the reconstitution as Ruston, Burton and Proctor. Within 6 months, Burton had walked out. The records say he disagreed with his partners. One suspects the disagreement had a name, and it was Joseph Ruston. The new arrival, not yet 23, had evidently made it clear whose vision would prevail. Ruston bought Burton's share, and the firm became Ruston, Proctor and Company. By 1865, Proctor himself had retired to the comfort of Osgoodby House, and Ruston, aged 30, a Methodist outsider in an Anglican cathedral city, was sole proprietor of a works that in 1861 had employed 156 men and boys. The speed of it is remarkable. In less than a decade, a cutler's apprentice from a fen farm had elbowed aside both founding partners of an established Lincoln firm and made it entirely his own. This wasn't inheritance or patronage at work. This was will, and he had married well. In 1859, Ruston wed Jane Brown, daughter of William Brown of the Sheffield and Rotherham Banks. Sheffield banking capital, the same financial networks that had underwritten the cutlery trade, now underwrote Lincoln engineering. Every expansion that followed, every new bay added to the sheaf iron works on Waterside South, carried the invisible signature of that marriage. Jane Brown's dowry wasn't just money, it was access to the kind of patient, industrial capital that Victorian manufacturing required and that Lincoln's local banks couldn't always provide. What Ruston built with it was formidable. By 1885, when members of the Institution of Mechanical Engineers toured the Sheaf Iron Works, the site covered 13 acres, 3 cupola furnaces fed the foundry. A boiler shop equipped with hydraulic riveters turned out the pressure vessels that were the beating heart of every portable engine. A smith's shop of over 50 hearths rang with the percussion of men shaping iron by hand. Fitting and erecting shops covered 2 acres. The workforce had grown to 1,400. But the numbers only tell part of it. What made Ruston, Proctor distinctive, what separated it from the cluster of Lincoln engineering firms already thriving along the Witham, was its proprietor's appetite for the world beyond Lincolnshire. An anecdote from Bernard Newman's centenary history, 100 Years of Good Company, captures the instinct perfectly. Ruston travelled to Russia to sell steam pumps for fen-style land drainage, the technology of his childhood landscape, exported. While there, he was told that another man wanted to pump something else out of the ground. Oil. Ruston sold him a pump. The Baku oil fields were opening up. The drainage engineer from Chatteris saw no reason why his machines shouldn't drain petroleum as readily as water. It was pure opportunism, and it was the making of the firm's export reputation. By the time of his death in 1897, Ruston Proctor had produced over 42,000 engines and employed 2,000 people. The Sheaf Iron Works had become one of the largest engineering establishments in the East Midlands. The man himself had become Lincoln. He built Monk's Manor on Greetwell Road in 1877, modelled with characteristic ambition on Queen Victoria's Osborne House on the Isle of Wight. 25 acres of grounds, a purpose-built picture gallery designed by Major F. H. Goddard for a serious Victorian art collection. He served as Mayor of Lincoln in 1869–70, stood as Liberal MP for Lincoln from 1884 to 1886, breaking with Gladstone over Irish Home Rule, a principled stand that cost him his seat, and was appointed High Sheriff of Lincolnshire in 1891. The French gave him the Legion of Honour. The Ottoman Sultan gave him the Order of the Osmanieh. Both were for export work, Ruston engines pumping water in Egypt, driving mills in Turkey, draining fields across the Russian steppe. He funded Lincoln's Drill Hall, endowed a children's ward at Lincoln County Hospital, and, despite his lifelong nonconformity, despite the social distance between Methodist Chapel and Anglican Cathedral, paid for the restoration of the Queen Eleanor Monument in Lincoln Cathedral Close. He became chairman of the Lincolnshire Echo at its founding in 1893. When he died at Monk's Manor on June 10, 1897, aged 62, the obituary in the Engineer spoke of great energy and assiduity. The word is perfectly chosen. Assiduity, relentless, sustained, purposeful effort. It is the word for a man who arrived in Lincoln with a cutler's apprenticeship and a small inheritance, and left it as the city's most powerful industrialist, with a house modelled on a queen's and a factory that stretched along the waterfront like a declaration of intent. But Ruston left something else, something that would matter more than the house, the gallery, or the civic honours. In the mid-1870s, he had bought patents from the Scottish engineer James Dunbar for a rail-mounted steam excavator. The machine was crude by later standards, a boiler on a rail chassis with a rope-operated bucket, but it could move earth faster than 100 men with shovels, and Ruston saw, with the same mercantile instinct that had sold pumps to Russian oilmen, that the future of civil engineering would be mechanical. What happened next was the proof. Chapter 2. 71 Navvies and a Ship Canal. Between 1887 and 1893, 71 Ruston steam navvies dug the Manchester Ship Canal. The scale of that project is difficult to grasp at this distance. 36 miles of excavation from Eastham on the Mersey to Selford Docks, cutting through sandstone, clay and glacial till, requiring the removal of roughly 54 million cubic yards of spoil, the largest civil engineering project in Victorian Britain, conceived to free Manchester's cotton mills from Liverpool's dock charges. At peak construction, over 16,000 navvies worked the line, and alongside them, doing the work of hundreds of men each, were Ruston's machines. 2 of them, one working from each end of the canal, cut the final spoil that joined Manchester to the sea. When the ship canal opened on January 1st, 1894, with Queen Victoria sending a telegram of congratulation, the machines that had made it possible bore the name of a Lincoln firm, founded by a Methodist cutler's apprentice from a Cambridgeshire fen. The firm that would terraform Britain had learned to do so on the banks of the Mersey. The Manchester Ship Canal wasn't just a commercial triumph. It was a demonstration, conducted in front of every civil engineer in the country, that Ruston's excavators worked, reliably, at scale, in the most demanding conditions Victorian engineering could devise. Orders followed. The Sheaf Iron Works expanded, and the question of why Lincoln, of all places, had become the cradle of British heavy engineering resolved itself into a set of geographical facts so precise they read like an industrial blueprint. Lincoln sat at the convergence of four things that heavy engineering required. First, water. The Roman origin Fossdyke navigation and the navigable River Witham gave direct waterborne access to the Trent and Humber ports at Hull and Gainsborough, and south to Boston for the North Sea. Portable engines and boilers, too heavy for most roads, left waterside south by barge. Second, railways. Four major lines, Great Northern, Great Eastern, Manchester, Sheffield and Lincolnshire and Midland, converged on the city by the 1850s, placing Lincoln at the junction of routes running north to York, south to London, east to the coast, and west to Sheffield and Manchester. Third, market. Lincoln sat at the edge of Britain's largest mixed farming region, and the mechanisation of threshing and fen drainage created insatiable demand for the portable steam engines that were every Lincoln work's bread and butter. Fourth, and perhaps most important, people. By 1885, when the Emeki visitors arrived, Clayton and Shuttleworth at Stamp End employed 1,700 hands, Ruston, Proctor employed 1,400, and Roby at the Globe Works employed 1,100. Roughly 1 in 3 adult men in Lincoln worked in these firms. The city didn't just have engineering works, it was an engineering city, a dense, self-reinforcing ecology of millwrights, fitters, boilermakers, pattern makers, and foundrymen whose skills passed from father to son and whose community institutions, the pubs, the chapels, the mechanics' institutes, were built around the rhythm of the works hooter. That IMECHE visit in 1885 produced one more detail worth its own scene. As the visiting engineers toured the Sheaf Iron Works, Joseph Ruston himself demonstrated a Dunbar and Ruston steam navvy, under steam, working, moving earth, while reading his newspaper. The gesture was deliberate. "This machine works, gentlemen. It works so well that its proprietor can read the morning news while it operates." The showmanship was pure Ruston, the Methodist outsider who knew that a demonstration was worth 1,000 specifications. He had 4 years left to live. The firm he'd built from a failing millwrights would outlive him by over a century, and the steam navvies he'd championed, those clumsy, rope-hauling, coal-burning beasts, were the ancestors of every excavator that would follow, including the machines that would one day bear a name compounded from 2 continents, Ruston-Bucyrus. Chapter 3. The Arsenal at Full Tide. On 12th of July 1889, 8 years before his death, Joseph Ruston converted the firm to limited liability as Ruston, Proctor and Company Limited, capitalised at £500,000 with 1,600 employees. It was a practical decision. The works had outgrown the resources of any single proprietor, but it also marked the moment when the firm stopped being one man's vision and became an institution. By 1911, the cumulative output stood at staggering figures: 42,800 engines, 36,880 boilers, 5,200 centrifugal pumps, 600 excavators, 2,400 threshing machines. By 1914, the workforce was 5,200. The Sheaf Iron Works wasn't a factory any longer. It was an industrial district. Running the firm after Joseph's death in 1897 was his son, Colonel Joseph Seward Ruston, born 1869, the heir who'd grown up in Monk's Manor, educated in the certainties of late Victorian Lincoln, and who would steer the works through the most transformative decade in its history. Because what happened between 1914 and 1918 turned Ruston Proctor from an agricultural engineering firm into something far larger, far more complex, and far more entangled with the British state. The First World War made Lincoln an arsenal. Ruston, Proctor became Britain's largest aero-engine builder, producing around 3,000 engines across multiple types for the Royal Flying Corps and its successor, the Royal Air Force. But the firm didn't just build engines. It built the aircraft they powered. Roughly 2,750 aircraft left the Botham Works between 1914 and 1918. Approximately 1,600 Sopwith Camels, the fighter that did more than any other to wrest air superiority from the German Jagdstaffeln, along with 250 Sopwith 1.5 Strutters and 200 RAF BE-2s. The 1,000th Camel, serial B7380, was christened Wings of Horus in 1917, a moment of production pride recorded in the firm's internal history. Over 3,000 people worked on aircraft alone. The scale of the transformation deserves a moment's thought. In 1913, Ruston-Proctor was building threshing machines, portable engines, and a modest line of steam excavators. By 1916, it was building one of the most lethal fighter aircraft in the world. Fabric-skinned biplanes with rotary engines and synchronized Vickers guns, delivered in numbers that only a firm with deep reserves of skilled metalworkers and a management accustomed to complex production could achieve. Colonel J.S. Ruston, now High Sheriff of Lincolnshire in 1917, watched the works he'd inherited from his father become a pillar of the British war effort, and the workforce had changed. By 1916, over 600 women worked at the Botham Aero Factory, initially on aircraft fabric stitching, the work considered appropriate for female hands, but progressively on heavier tasks, turning shells, forging ingots, working in boiler suits alongside the men who remained. The Lincoln Works, like every major British engineering firm, discovered during the war that women could do the work. After the war, like every major British engineering firm, it largely forgot. The war also produced a weapon from within the Ruston family itself. Captain William Howard Livens, a director's son, developed the Livens projector, a crude but devastating gas mortar that could saturate an enemy position with phosgene shells in a single salvo. The projector was manufactured at Lincoln. So was what the engineer called the largest bomb of the war. The works that had started with steam pumps for Cambridgeshire fens was now building weapons of industrial slaughter. It is one of the less comfortable threads in the Ruston story, but it is part of it. The armistice brought crisis. War contracts evaporated. The civilian order book was thin, and on 11th September 1918, before the fighting had even stopped, Ruston-Proctor amalgamated with Richard Hornsby and Sons of Grantham. The new firm was Ruston and Hornsby Limited. The merger made strategic sense. Hornsby, founded in 1828, brought hot bulb oil engine technology. Patented in 1891, 8 years before Rudolf Diesel's commercial engine reached market. This was Lincoln area engineering, solving the portable power problem before the man whose name became synonymous with it. But Hornsby also brought something else, and here the story takes one of its most jarring turns. In 1908, Richard Hornsby and Sons had developed and patented a chain-track tractor, a crawler system that allowed heavy machinery to cross soft ground without sinking. The patent was promising but expensive, and Hornsby, a smaller firm with thinner resources, couldn't afford to develop it at scale. In 1913, the company sold the patent to the Holt Manufacturing Company of Stockton, California. Holt, in 1925, merged with the CL Best Tractor Company to form the Caterpillar Tractor Company of Peoria, Illinois. The firm that would eventually kill Ruston-Bucyrus, the hydraulic pioneer that would spend 4 decades eating the market Lincoln refused to adapt to, bought its foundational technology from a works 35 miles down the road in Grantham. The crawler track that would carry every Caterpillar excavator in history started life in Lincolnshire. Colonel J.S. Ruston and the Hornsby directors likely didn't lose sleep over the sale. Chain-track tractors were a niche product in 1913. Oil engines and excavators were where the money lay. But the irony, viewed from the far end of the century, is painful enough to leave a mark. The newly merged Ruston and Hornsby tried one spectacular detour in the post-war years. Between 1919 and roughly 1924, the firm built approximately 1,500 motorcars, heavy, expensive machines priced between £440 and £1,000, designed by Edward Boulton, the chief engineer who'd worked on wartime tank production, and who clearly believed that Lincoln's metalworking skills could transfer to the motor trade. They couldn't, not at that price, not at that weight, and not against Morris, Austin, and the emerging volume producers who understood that the British car market wanted cheap, light, and reliable, not overbuilt and expensive. The Ruston car died quietly. Bourton left to found Automotive Products in Leamington Spa, where his engineering talent found a better home. It was the first clear signal that Ruston and Hornsby's instinct to build heavy, to build robust, to build what they knew, could be a weakness as well as a strength. But the most revealing episode of the immediate post-war years wasn't the car, it was Swanpool Garden suburb. In 1919, Colonel J.S. Ruston acquired 25 acres of the Baltham Hall estate, adjacent to the works, and commissioned Hennell and James of London to design an arts and crafts housing development for Ruston workers. The plan was revolutionary. There would be no coal fires and no gas. Waste steam piped from the adjacent Ruston works would supply central heating and hot water. Electricity would come from a central generating station. The cottages, steep-roofed, tall-chimneyed, designed with the quiet confidence of Edwardian idealism, were intended to house 2,000 to 3,000 people in a self-contained workers' community where the employer provided not just wages, but warmth, light, and a designed landscape. Between April 1919 and September 1920, only 113 houses were built. Financial reality, post-war inflation, the cost of the steam heating infrastructure, the sheer ambition of the plan, defeated Ruston's vision. The estate was sold to commercial developers in 1925, but those 113 cottages survived. They sit today in a softly geometrical road network. Curley Avenue, named for Muriel Curl, wife of Joseph Seward Ruston, an accidental museum of what British industrial paternalism aspired to before the money ran out. Swanpool tells you something essential about the culture of Lincoln engineering in the 1920s. These were firms that believed they would last forever. They built housing for their workers because they expected those workers' grandchildren to walk through the same gates. That belief, in permanence, in the self-evident rightness of heavy engineering, in the assumption that what Lincoln built would always be needed, was the foundation of everything that followed. It was also, in the end, the thing that made the fall so hard. Through the 1920s, Ruston and Hornsby built oil engine excavators under license from Bucyrus Erie of South Milwaukee, Wisconsin. The American firm was itself a 1927 merger. The Bucyrus Foundry of Bucyrus, Ohio, founded in 1880 with $17,000 in capital from Cleveland banker Daniel P. Eales and designs by master mechanic John Thompson, combined with the Erie Steam Shovel Company. Bucyrus had supplied 77 of the 102 steam shovels used to dig the Panama Canal between 1904 and 1914, each machine averaging over 1 million cubic yards of culebra cut. The photograph of Theodore Roosevelt seated on a Bucyrus shovel in 1906, white suit and pith helmet against the brown dirt of the cut, remains the most famous image in excavation history. By the late 1920s, the two firms needed each other. Bucyrus Erie, under President W. W. Coleman, promoted in 1911, a man who would run the company for an extraordinary 46 years until his retirement in 1957, wanted access to the British Empire market without paying British import tariffs. Ruston and Hornsby wanted modern American excavator designs to replace its aging steam navvy lineage. The negotiation was conducted on the British side by Colonel J.S. Ruston, the founder's son, on the American side by Coleman, the long-reigning Milwaukee executive. In 1930, the two firms formed Ruston-Bucyrus Limited, a 50-50 Anglo-American joint venture. Bucyrus Erie held operational control. Ruston and Hornsby transferred its entire excavator division into the new company and retained engines, locomotives, and what would later become a quietly transformative gas turbine business. The factory on Beaver Street, running roughly 900 meters along its southern flank, over 30 bays deep, each bay about 150 meters long and fitted with overhead cranes, became the joint venture's manufacturing heart. The name was new. The bricks were old. And inside those bricks, a generation of Lincoln engineers was about to build machines that would dig the coal, shift the overburden, and reshape the surface of Britain on a scale that Joseph Ruston, reading his newspaper beside a steam navvy in 1885, could scarcely have imagined. The question, the one that would take 70 years to answer, was whether those engineers would be allowed to build the right machines when the world changed beneath them. Chapter 4. The Cathedral of Steel. The factory that Ruston-Bucyrus inherited on Beaver Street in 1930 was already vast. What the joint venture built upon it over the next 3 decades was something closer to a self-contained industrial civilization. The site ran roughly 900 meters along Beaver Street's southern flank, the best part of half a mile of continuous factory frontage, stretching from the eastern entrance near Firth Road to the western bays, where the largest machines were assembled. Behind that frontage, the works extended up to 400 meters deep, organized into more than 30 numbered bays, most of them approximately 150 meters long and fitted with overhead traveling cranes running on rails bolted to the steelwork high above the shop floor. The bay numbers weren't just administrative, they were a geography. Workers didn't say they worked in the machine shop or in assembly. They said they worked in 5 Bay, or 22 Bay, or number 3. The number was their address, their tribe, their corner of a world so large that a man could work there for 30 years and never set foot in every building. Number 1 Bay housed what the men called the Big Planer, a Noble and Lund horizontal planing machine with twin 50-foot beds, described by one former worker as the biggest in the country. Its job was to machine the side frames of the flagship 150-RB electric face shovel, components so large that the planing operation alone took days. The sound of the Noble and Lund, a deep, rhythmic shearing of metal, the cutter head advancing across a steel plate the size of a terrace house wall, was the bass note of the western end of the works. Number 3 Bay was the erecting shop, and it stopped people in their tracks. A young apprentice named Taffy, a teenager from Swansea who arrived in the early 1960s for a 5-year apprenticeship and who would later write the memoir Building the Iron, described it as being like a cathedral in there, it's so high. Can you believe 80 feet? 80 feet from the oil-stained concrete floor to the underside of the roof trusses. The bay cranes moved overhead like slow mechanical birds, carrying loads that would have collapsed the floor of any ordinary building. Main revolving frames, the turntable assemblies on which every excavator's upper works pivoted, were set up on a Richards horizontal borer, the cutting tools chewing precision into castings that weighed several tons. In 5 Bay, gear teeth were generated on Sunderland planers, each tooth cut to tolerances measured in thousandths of an inch, because the gears that drove a dragline bucket through clay and shale and coal-bearing overburden could not afford to be approximate. Almost everything except iron founding was done on site. Steel plate arrived by rail and left as excavators. Between those 2 points, the Beaver Street works cut, welded, machined, bored, planed, assembled, wired, painted, and tested every component. The machine shop smelled of coolant fluid, warm, faintly antiseptic, the kind of smell that clung to overalls and announced to anyone on the bus, home that you worked at RB. The welding bays smelled of electric arc, dry, acrid, catching the back of the throat. The fettling shop, where rough castings were ground and cleaned, produced a choking, rusty dust that, as one worker put it, you could almost taste. And in the test areas, where completed machines ran their engines for the first time under load, the smell was diesel fuel, the pervasive, invasive, won't-come-out-in-one-bath diesel that seeped into skin and fabric and shoe leather. On the larger engines, the test fuel was heavy fuel oil, so thick it had to be heated before it would flow, so corrosive that it rotted the soles off shoes in weeks. Workers in the test areas went through footwear the way other men went through socks. The noise was extraordinary. Derek Broughton, a grammar school boy from Lincoln who joined as a craft apprentice in the autumn of 1959, the one solitary grammar school boy among 30 secondary school entrants that year, would later describe the Beaver Street Research Centre in terms that read like an assault briefing. A 16-cylinder Ruston engine at full power produced the simultaneous clatter of 16 sets of valve gear, the percussion of 16 pistons, each the size of a small dustbin, turning at 400 revolutions per minute, and the scream of hundreds of cubic feet of air per second being forced through twin turbochargers. Hearing protection was cheap boxfuls of disposable soft rubber earplugs. They helped. Not enough. Injuries were common. Fatalities were occasional. The works operated under the assumptions of its era, that heavy engineering was inherently dangerous, that men who worked with hot metal and moving cranes accepted risk as part of the wage, and that the best protection was experience. An apprentice learned quickly which sounds meant danger, which crane movements required you to step aside, and which of the older men you should watch and imitate if you wanted to keep your fingers. The assembly process for a standard machine, the 22RB, the workhorse of the range, followed a logic that Taffy's memoir traces in vivid detail. In Number 3 Bay, the slingers, men named Bob and Bino in Taffy's account, worked with pairs of 20-ton revolving frames hanging on chains from the overhead cranes. Their job was to float the upper works across the bay to marry with the lower carriages, crawler tracks, drive motors, the steel understructure that waited on the assembly stands below. The word float is deceptive. These were multi-ton steel assemblies moving through the air on chains, guided by hand signals and the slinger's judgment, with tolerances that left inches between the descending upper works and the men standing beside the lower carriage ready to guide it home. When the two halves mated, upper to lower, the bolt holes aligning, the pins dropping into place, the machine that emerged was a complete excavator, ready for wiring, hydraulic connection, and the fitting of its front-end equipment: face shovel, dragline bucket, back actor, crane hook, grab, pile driver. One base, 8 possible configurations. The universal platform was Ruston-Bucyrus's engineering philosophy made physical. At peak production in 22 Bay, the line was turning out nearly 12 22RB machines a week, 12 excavators, every 7 days, each one a working machine capable of digging foundations, stripping overburden, loading haul trucks, or driving piles, depending on which front end the customer specified. The 22RB was powered by the Ruston and Hornsby 6YDA, a 6-cylinder air-cooled diesel that the parent company supplied across the road, and that gave every machine on site the distinctive Ruston sound, a hard, rhythmic bark, quite unlike the smoother note of the water-cooled engines its competitors used. The test ground sat beyond the final assembly bays, and its cranes could lift 120 tons. A completed 71 RB excavator, over 60 tons of steel, diesel, and cable, would sail overhead on the bay cranes, carried from the erecting shop to the test ground like a ship being launched in slow motion. An apprentice, watching this spectacle, joked that if the crane hook were placed in one goalmouth at Sinshill Bank, Lincoln City's football ground, a few hundred yards away, the jib of a 71 RB would hang in the centre circle. It wasn't quite true, but it wasn't far off either. Chapter 5. The town the works built. The men who built those machines lived, overwhelmingly, within walking distance or a short bus ride of the Beaver Street gates. Boltham, New Boltham, Bracebridge, St. Catherine's, and Swanpool, the residential districts south and west of the city centre, were Ruston territory. A man leaving his terrace house at 6:45, walking down streets where every other household had someone at the same works, arriving at the gates alongside 3,000 others as the works hooter sounded. This was the daily rhythm of a community organised around a single employer on a scale that is difficult to recover now. Multi-generational employment was the norm, not the exception. Derek Broughton's family history is the representative case. His grandfather had been a Ruston man for 50 years, a commissioning engineer who travelled all over the world in the days of steamships, installing and testing Ruston equipment on distant sites, then coming home to Lincoln and the same works he'd left. Broughton's father worked at the same firm. When the 16-year-old grammar school boy walked through the gates in the autumn of 1959, he was the third generation of his family to do so. Across the works, the pattern repeated. Fathers brought sons, uncles recommended nephews. The interview for an apprenticeship was often a formality. The real assessment had been made over years on the streets where Ruston families lived beside other Ruston families, in the pubs and social clubs where reputation was communal knowledge. Those institutions were the connective tissue of the community. The Ruston Sports and Social Club on Newark Road was the firm's own, the place where workers drank, played darts, watched turns on a Saturday night, and organised the sporting life that gave the works a second identity beyond the factory gates. Ruston Sports FC, founded in 1972 as the social club football arm, was its most visible expression, but there were cricket teams, bowls leagues, fishing clubs, and the annual works outing, the kind of communal expedition that British factories organised with a seriousness that bordered on military logistics. Lincoln's street map carried the Ruston name into the landscape. Ruston Way, off Tritton Road, commemorated Sir Joseph Ruston. Curl Avenue honoured Muriel Curl, wife of Joseph Seward Ruston. Beaver Street itself took its name from Elizabeth Beaver of the Ellison family of Boltham Hall, the aristocratic landowners whose estate had been progressively eaten by industrial development since the mid-19th century. And Tritton Road, the arterial spine connecting the works to the wider city, commemorated Sir William Ashby Tritton, managing director of William Foster and Company, co-inventor of the tank, a reminder that Lincoln's engineering dynasties were interwoven at the level of geography as much as industry. The Union presence was divided along skill lines, as it was in every British heavy engineering works of the period. Skilled trades, the fitters, the turners, the machinists, the electricians, were represented by the AEU, the Amalgamated Engineering Union, which became the AUEW after its 1971 merger. General workers, labourers, crane drivers, storemen were TGWU, the Transport and General Workers Union. The two unions coexisted in the same factory, but operated in distinct cultures. The AEU men tended to see themselves as aristocrats of the shop floor, whose time-served apprenticeships set them apart. The TGWU men did the work that kept the whole operation moving, but carried less bargaining weight. The tensions between the two, over differentials, over demarcation, over who was entitled to do what, were a running feature of post-war British engineering, and were no less present at Beaver Street than anywhere else. The most documented local labour action involving Ruston workers wasn't a factory dispute at all. It was the 1921 Lincoln Corporation rent strike on Ragby Road, in which Ruston employees joined the Independent Labour Party in demanding better post-war housing. The war had promised homes fit for heroes. The reality, in Lincoln as in every British industrial city, was cramped, damp and overcrowded. Ruston workers had built Sopwith camels, they had built aero engines, they had built bombs, and they'd come home to streets that hadn't changed since their grandfather's time. The rent strike was a small thing, quickly settled, but it captured a mood that the 113 cottages of Swanpool Gardens suburb had been designed to address, and that the suburb's failure had left unresolved. Women's employment at RB after the Second World War followed the wider British pattern, a wartime surge, a post-war retreat, and a slow, partial return. During the war, women worked across the Lincoln Works in roles that ranged from clerical to semi-skilled production, the same pattern as 1914 to 18, reprised a generation later. Afterwards, most returned to domestic life or to the lighter industries that employed women on Lincoln's northern side. By the 1950s, the Beaver Street Works was overwhelmingly male, a world of heavy steel, overhead cranes, and physical danger where the working culture assumed, without much questioning, that the shop floor was a man's domain. Women worked in the offices, in the stores, in the canteen. They did not, as a rule, work in 3 Bay or on the test ground. Whether that was protection or exclusion depended on who you asked and when you asked them. The community that the works sustained, the houses, the streets, the pubs, the clubs, the schools that fed apprentices into the gates every September, was built on an assumption so fundamental that nobody thought to state it. The works would always be there. Lincoln would always be an engineering city. A lad who started his apprenticeship at 16 could expect, if he kept his head down and learned his trade, to retire from the same works at 65. Broughton's 3-generation family was not unusual. It was the plan. Chapter 6. The largest in the world. At its peak, and the peak is locatable, somewhere between 1958 and 1965, Ruston-Bucyrus was the largest excavator manufacturer in the world by unit output. The claim was not hidden. A girder bridge over Lincoln's High Street, visible to every passenger stepping off the train at Lincoln Central, carried a painted sign announcing the fact, the largest excavator manufacturer in the world. It was the kind of declaration that a more cautious firm might have left to the trade press. Ruston-Bucyrus put it where the whole city could read it. The product range justified the confidence. The model numbering system, where the figure corresponded roughly to the standard face shovel bucket capacity in cubic feet, ran from the compact 10 RB at the bottom to the colossal 150 RB at the top, with the 17 RB, 19 RB, 22 RB, 30 RB, 38 RB, 54 RB, 61 RB and 71 RB filling the middle ground. Each model shared the same fundamental platform philosophy, a crawler-mounted base carrying interchangeable front-end equipment: face shovel, dragline, skimmer, back actor, crane, grab, pile driver. One machine, 8 configurations. The customer bought a platform and specified the task. It was elegant, it was versatile, and it was what Lincoln knew how to build better than anyone else in the world. The 22RB, powered by its Ruston and Hornsby 6 YDA 6-cylinder diesel, was the runaway bestseller. Secondary source estimates suggest total production across the 22RB family of around 10,000 units, a figure that made it the defining British excavator of the mid-20th century. 10,000 machines, each one assembled in the bays off Beaver Street, each one tested on the proving ground beyond, each one shipped by rail or road to building sites, quarries, open-cast mines, and civil engineering projects across Britain and the world. If you dug a foundation in Britain between 1950 and 1975, the chances are a 22RB was within earshot. Above the standard range sat the electric machines. The 110RB was a 154-ton electric face shovel. A preserved example at Threlkeld Quarry in Cumbria still operates on a 3.3 kilovolt supply, a working monument to Lincoln engineering. The 150-RB, the flagship, was a 6 cubic yard electric shovel, assembled in the dedicated large bay at the western end of the works. The bay with the highest cranes, the widest doors, and the most floor space, because the 150-RB was a machine that required its own architecture, and above even the 150-RB sat the walking draglines, the colossi that terraformed Britain's open-cast coalfields. The Bucyrus Monaghan 5W was the workhorse of the fleet, but it was the larger machines that entered legend. The 380-watt Little John and the 480-watt Big John worked British opencast through the 1960s and 1970s. The 1,260-watt Shevington Collier, weighing around 3,500 tons, carrying a 32 cubic metre bucket on a 54-metre boom, operated at Maiden's Hall and East Shevington in Northumberland into the 2000s. Each walking dragline was less a machine than a mobile structure. The American equivalent, the Big Muskie, stood 22 stories tall. Miles of electrical cable fed them. Internal stairs connected operating levels. Crews rotated through shifts aboard what amounted to a small industrial building that happened to walk. The names the crews gave them are worth recording because they capture the relationship between men and machines that defined this industry. Little John and Big John. Shevington Collier. The BE-115-0-B Oddball at St. Aidan's. The BE-155-0-W, Big Geordie at Butterwell. These were machines with characters, particular sounds, particular handling quirks, particular reputations among the men who operated them. Exports carried the RB name across the world. South African gold and coal mines, Australian coalfields, Indian civil engineering projects, Soviet pipeline trenches and irrigation canals, Dutch clay pits, where a 22RB reportedly sat at Rodruza into the 21st century, still working, decades after the firm that built it had ceased to exist. The global reach was a point of institutional pride that went back to Joseph Ruston, selling pumps to Baku and his grandson's commissioning engineers, travelling by steamship to install machines on distant continents. The domestic empire was British open-cast coal. At the giant Masgwyn site in South Wales, Wimpey's 1963 fleet read like a Ruston-Bucyrus catalogue. 338RB shovels, 222RB draglines, 1RB 150RB, 1RB 110RB crawler dragline, working alongside 3 imported Bucyrus Erie 150-B shovels and the Ransoms and Rapier W1800 Big Lady, which at 2,000 tons was the world's largest walking dragline when commissioned in 1961. Westfield in Fife, Stobswood and Butterwell in Northumberland, Shevington, St. Aidan's in Yorkshire, Carrington's Coppice in the Midlands. The map of Britain's opencast industry was, in practical terms, a map of Ruston-Bucyrus's order book. What made RB dominant, what kept it ahead of Priestman Brothers of Hull, NCK of Sheffield, Ransoms and Rapier of Ipswich, and Thomas Smith of Rodley in Leeds, was fourfold. First, the Bucyrus Erie Design Library, which gave Lincoln access to American engineering data accumulated over decades. Second, in-house Ruston and Hornsby diesels, which meant RB controlled its own power supply chain. Third, the sheer physical scale of the Beaver Street works. No British competitor had anything close to 30 bays and 900 metres of factory frontage. And fourth, the modular universal platform backed by 8 UK service depots, which meant a customer buying one machine was buying into an ecosystem. It was by any measure an extraordinary achievement. A works founded by a Methodist cutler's apprentice from a Cambridgeshire fen, merged with an American shovel company from Ohio, operating from a Victorian factory in a cathedral city on the Lincolnshire plain, had become the largest excavator manufacturer on earth. The bridge over the High Street said so. The order book confirmed it. Chapter 7. The Summit and the Shadow. Between 1958 and 1965, everything at Beaver Street pointed upward. The 22 RB was rolling off 22 bay at nearly 12 units a week. The payroll stood at somewhere between 2,600 and 3,000, depending on whether you counted the permanent establishment or included contractors and subcontractors on site. The walking dragline components were stacked in the yard, waiting for assembly and dispatch to the open-cast sites that were reshaping the surface of northern England. The 150 RB electric shovels stood in the big bay like monuments to Lincoln's confidence in its own future. Across the road, the parent company was entering its own era of ambition. Ruston and Hornsby's gas turbine business, founded in 1946 under Bob Filden's CBE, who had taken up the challenge on encouragement from Frank Whittle himself, the jet engine pioneer, delivered its first production unit in 1952, a 1-megawatt TA turbine shipped to Kuwait Oil. It was a modest beginning for what would become the sole lasting survivor of the Lincoln engineering tradition. In 1950, the Beaver Foundry opened, claimed at the time as the largest in Europe, and the group's collective confidence was at a height that made the Swanpool Garden suburb ambitions of 1919 look timid by comparison. This was the Lincoln that Derek Broughton walked into in the autumn of 1959. A 16-year-old grammar school boy, the one solitary grammar school entrant among 30 secondary school apprentices, sent into the Cathedral of No. 3 Bay, where it was assumed, not hoped, not wished for, assumed, that any lad who completed the 5-year programme would have a job for life. Broughton's grandfather had worked at Ruston for 50 years. His father worked there. The expectation was that Broughton would complete the set. 3 generations under the same roof, building machines that dug the modern world. It was the natural order of things. The warning signs were there, but they were small and distant, and easy to dismiss from a works floor that shook with the sound of 16-cylinder Rustons at full power. In France, Poquelin had delivered its first hydraulic excavator, the tractor-towed TU, in 1951. In Rochester, Staffordshire, Joseph Cyril Bamford's JCB had shipped its backhoe loader Mark I in 1953 and the transformative JCB 3C in 1963, the machine that would define the small to medium earth-moving market for a generation. Hitachi's UH-03, the first all-Japanese technology hydraulic excavator, arrived in 1965, and Bucyrus Erie itself, RB's own American parent, had in 1963 signed a license agreement with Komatsu of Japan, allowing Komatsu to build Bucyrus-designed hydraulic machines for the Asian market. The hydraulic excavator worked differently from the cable machine. Instead of wire ropes and drums and fair leads, the mechanical complexity that cable operators spent years learning to handle with precision, hydraulics used pressurized oil to drive cylinders that moved the boom, stick, and bucket directly. Faster cycle times, better operator comfort, fewer wear parts, more versatile front-end configurations, lower skill requirements. On a 1-yard backhoe, the hydraulic machine was demonstrably superior to the cable equivalent by the mid-1960s. But here is the thing about looking at the world from the summit. From Beaver Street in 1962, with 12-22 RBs a week leaving 22 bay and walking draglines on order for every major open-cast site in Britain, the hydraulic excavator looked like a toy. A useful toy, perhaps, for digging house foundations and laying sewer pipes, but not a serious threat to the cable machines that dug coal seams and shifted hundreds of thousands of cubic yards of overburden per month. The JCB 3C was a backhoe on a tractor chassis. The 150-RB was a 200-ton electric shovel with a 6-yard bucket. They did not compete in the same world. That analysis was not entirely wrong. At the very largest end, Mining shovels, big draglines, cable and rope would hold on for decades because of sheer reliability, lift capacity, and the deep conservatism of mine purchasing departments who knew what a cable machine could do and didn't trust what a hydraulic machine might do. The problem was that the very largest end was a small and shrinking fraction of the total excavator market. The growth was in the middle, the 2 to 5 yard range, and in the middle, hydraulics was winning. The bridge over Lincoln's High Street still carried its sign, the largest excavator manufacturer in the world. In 1962 it was still true, but the world the sign described was already contracting, and the men who might have done something about it were not, for the most part, at Beaver Street. They were in South Milwaukee, where Bucyrus Erie held operational control. And in South Milwaukee, the commitment to cable and rope ran deeper than any single product decision. It was woven into the company's identity, its engineering culture, its institutional memory. Bucyrus had dug the Panama Canal with cable shovels. Bucyrus Erie had built the largest draglines on Earth. Cable was what they knew. Cable was what they were. The sign over the high street was, without anyone realizing it, a monument to a peak that had already passed. Chapter 8. The revolution Lincoln watched from its window. The hydraulic excavator didn't arrive as a single threat. It arrived as a dozen, from a dozen directions, each one eating a different slice of the market that Ruston-Bucyrus had assumed would remain forever cable-operated. Pokeland's TY-45, launched in 1961, was the first full-slewing hydraulic excavator, a machine that could rotate 360 degrees on its base, just like a cable machine, but with hydraulic cylinders doing the work that wire ropes and drums had done for 70 years. It sold 30,000 units over 21 years. 30,000. The entire production run of the 22 RB, RB's bestseller, the machine that had made the bridge over the high street true, was roughly 10,000 units across its full lifespan. Pokeland outsold it 3-1 with a single model. JCB's trajectory was steeper still. The 3C backhoe loader, launched in 1963, defined a market segment that hadn't existed a decade earlier, the versatile mid-size machine that could dig, load and grade on a building site without requiring the specialist operators that cable excavators demanded. By 1964, JCB had introduced its first crawler, 360-degree excavator, the JCB-7, built under a Warner and Swayze license. Joseph Cyril Bamford understood something that the men in South Milwaukee and the engineers on Beaver Street were slow to grasp. The future of earth-moving belonged not to the largest machines, but to the most versatile ones, operated by the least specialized labor, purchased by the smallest contractors. The economics ran downhill. Every year, the threshold at which a hydraulic machine outperformed a cable machine moved upward, from half-yard buckets to 1 yard, from 1 yard to 2, from 2 to 5. In Japan, the revolution was industrially systematic. Hitachi's UH-03 in 1965 was the first all-Japanese technology hydraulic excavator, designated Mechanical Engineering Heritage No. 48, a status that tells you how the Japanese regarded the achievement. Komatsu entered the hydraulic market via the very license that Bucyrus Erie had signed in 1963, producing the Komatsu Bucyrus 15HT, 20HT, and 22B. The license was supposed to give Bucyrus a route into the Japanese market. What it actually gave was Komatsu a masterclass in excavator engineering, taught by its future competitor, at Bucyrus's own expense. The Komatsu license would boomerang spectacularly. Barred from selling KB machines in the American market under the license terms, Komatsu sued Bucyrus Erie for restraint of international trade. The license was terminated in March 1981. Komatsu emerged from the wreckage as one of the world's dominant excavator manufacturers, no thanks to Milwaukee, and with a thorough working knowledge of Bucyrus design principles that it could now apply without restriction. The American parent had trained its own replacement. In Wales, at Rhymney, Hymac built 7,500 units of its 580 series, a hydraulic excavator designed for the British market by a British firm, proving that the technology wasn't exclusively Japanese or French. And in Peoria, Illinois, the headquarters of Caterpillar, the company whose very existence traced back to the Hornsby chain track patent sold from Grantham in 1913, the most ominous development of all was underway. Caterpillar's Model 225 was developed in secret from 1968, tested in the Arizona desert in 1970, and launched commercially in 1972. It carried a 125 horsepower Cat 316 OV8 engine, swung a 1-yard bucket, and it stayed in production for 15 years. The 225 wasn't Caterpillar's first hydraulic machine, but it was the one that established Peoria as a serious player in the excavator market that cable manufacturers had owned for generations. Caterpillar had the capital, the dealer network, the global servicing infrastructure, and the brand recognition to sell hydraulic excavators at a volume that no European specialist could match. When the 225 arrived on British building sites in the mid-1970s, the men at Beaver Street could see it from their window. The firm, whose crawler technology had been born in Lincolnshire, was now selling machines in Lincolnshire that made Lincoln's own products look slow, heavy, and old. The hydraulic case was overwhelming for machines in the small to medium class. Faster cycle times, a hydraulic back-actor could complete a dig-swing dump-return cycle in 15 seconds. A cable machine took 25. Better operator comfort. Hydraulic controls were levers and pedals, intuitive within hours. Cable controls were clutches and brakes, requiring months of training. Fewer wear parts. No wire ropes to inspect and replace. No fair leads to reline. No drums to re-grease. More versatile front ends. The hydraulic quick coupler, which allowed an operator to swap buckets in minutes, made the cable machine's 8-configuration universal platform look cumbersome by comparison. And lower skill requirements, which meant lower labor costs, which meant that a contractor buying a hydraulic machine could hire a competent operator in a week, rather than waiting for a 5-year apprenticed cableman who might or might not be available. On a 1-yard backhoe, hydraulics won by the mid-1960s. On 2 to 5-yard machines, by the mid-1970s. Only at the very largest end, mining shovels above 10 yards, walking draglines, did cable and rope hold on because of the sheer structural loads involved and the deep conservatism of mining company purchasing departments who operated machines for decades and didn't change technology without overwhelming reason. The tragedy of Ruston-Bucyrus is not that nobody at Beaver Street saw this coming, it is that some of them did. Chapter 9. The engineers who were proved right. The Lincoln engineers tried. This is the critical finding of the research, and the documentary must not bury it beneath institutional language. Real men, in a real factory, built real machines that could have changed the story, and were given too little resource, too late, to make a difference. In the late 1960s, after Bucyrus Erie's own American hydraulic designs had proved unsatisfactory, plagued by an outdated layout that routed propel drive through the upper works motor via a center pintle, a design that competitors had already abandoned, Lincoln was given autonomy to develop its own hydraulic line. The result was the 15RBH, introduced around 1967, a 360-degree hydraulic back-actor, designed and built at Beaver Street, that became popular in the Far East, and that is credited, in RB's own corporate history, with extending the life of the company. The 15RBH was followed by the 20RBH and the 30RBH, a family of hydraulic machines designed by Lincoln engineers who understood the technology, understood the market, and understood that the cable machine order book was a melting ice cube. Approximately 20 units of the 15RBH were built, 20, while JCB was building thousands, while Komatsu was building thousands. The reasoning for sticking with cable had some merit, viewed from inside the boardroom. RB's mining and open-cast customers still wanted cable machines. The walking dragline business remained genuinely world-leading. No one else could build what Lincoln built at that end of the market. The corporate muscle memory across both Lincoln and South Milwaukee was in cable and rope. Cable machines lasted longer in the field. Cable operators, once trained, were extraordinarily skilled. The mining companies that bought 110 RBs and 150 RBs and walking draglines didn't want hydraulic replacements. They wanted bigger, better cable machines, and they were willing to pay premium prices for them. The argument against was also being made, quietly, persistently, by the engineers who'd built the 15RBH and the 20RBH and the 30RBH. They could see the market data. They could see the competitor catalogues. They could see that every year the hydraulic threshold crept higher, from 1-yard machines to 2-yard, from 2 to 5, from construction sites to quarries to open-cast mines, and they could see that the investment required to scale a hydraulic line from 20 units to 2,000 was not coming. Not from South Milwaukee, where cable was identity. Not from the British parent, because by now the British parent had changed, and changed again, and the interests of Lincoln's engineers ranked somewhere below the interests of a conglomerate that had other priorities entirely. The corporate structure problem was as damaging as the technology bet. From 1966, Ruston and Hornsby was absorbed by English Electric. From 1968, English Electric was absorbed by the General Electric Company, GEC, under Arnold Weinstock. The strategic priority of the British parent shifted to gas turbines. The Lincoln Ruston Works became Ruston Gas Turbines in 1969, a renaming that told you everything about where GEC saw the future. Gas turbines were high-margin, high-technology products for the oil, gas, and power generation industries. Excavators were heavy steel for muddy holes. Under Weinstock's famously disciplined capital allocation, GEC was known in the city as a cash-hoarding conglomerate that would rather bank a profit than invest it in capability. The excavator division's claim on resources was structurally weak. A former Ruston finance director later observed that a bolder GEC could have turned Lincoln into a semiconductor power, building on what became the Dynex site. It did not. Weinstock's GEC was brilliant at financial management and disastrous at industrial strategy. The cash pile grew. The investment didn't come. And on Beaver Street, the engineers who could have built a hydraulic range to compete with Komatsu and Caterpillar watched the opportunity pass while the parent company counted its money. Meanwhile, the 50% Bucyrus Erie partner had its own problems. By 1982, Bucyrus Erie was acquiring Western Gear Corporation in a diversification play that went nowhere. By 1984, it had formed the defensive holding company Beckor Western to ward off hostile takeover bids. The American firm that was supposed to provide design leadership, market access, and capital discipline for the Lincoln joint venture was spending its energy on financial survival rather than product development. Between them, GEC on one side, Beckor Western on the other, the two parent companies drained the joint venture of everything it needed to compete in a market that was moving away from it at accelerating speed. The 15 RBH engineers were right. They were right about the technology, right about the market, right about the timeline. They built the proof. They never got the production run. Chapter 10. 5 decisions that closed the gates. The decline of Ruston-Bucyrus was not a single catastrophe. It was a sequence of decisions, each one made by identifiable people under identifiable pressures, each one closing off an escape route that might, with different capital, different ownership, different luck, have led somewhere else. The documentary's obligation is to name them plainly, without prosecution but without evasion. The first was the underinvestment in hydraulics at volume. The 15 RBH, the 20 RBH, the 30 RBH. These were programs of tens and twenties when the market demanded thousands. The responsibility didn't rest with any single individual. It was shared across the Ruston and Hornsby board under Ruston family successors and then English Electric, across the GEC parent under Weinstock's capital discipline, and across Bucyrus Erie's operational control under a succession of South Milwaukee chief executives through the 1960s and 1970s. The effect was cumulative and, by the late 1970s, irreversible. The growth segment of the excavator market, the segment where hydraulics had won, was now occupied by competitors who'd been investing at scale for 15 years. Ruston-Bucyrus couldn't catch up from a standing start with 20 machines a year. The window had closed. The second was the progressive erosion of the workforce through the 1970s. Peter Robinson's Lincoln's Excavators, the Ruston-Bucyrus. Years 1970 to 1985 describes the pattern, good times leading to expansion and the acquiring of the old Ruston Boiler Works, and the bad times with recession and redundancies, plus boardroom upheavals. The redundancies came in waves, not a single devastating round, but a long and dreary catalogue, as Derek Broughton later put it. Each wave took skills that wouldn't return. Each wave shrank the community of knowledge that had made the Beaver Street Works function, the men who understood the Noble and Lund planner, who could set up a Richards borer to thousandths of an inch, who could sling a 20-ton revolving frame on chains, and guide it home by hand. These skills were not listed in any manual. They lived in the hands and the habits of the men who possessed them, and when those men were made redundant, the skills walked out of the gates with them and didn't come back. The macroeconomic forces pressing on every round of redundancies were brutal and largely beyond Lincoln's control. The 1973-74 oil shock produced stagflation and the three-day week. The 1979-81 recession under early Thatcher monetarism. Chancellor Geoffrey Howe's tight fiscal policy, high interest rates designed to squeeze inflation out of the economy, and the sharp appreciation of sterling on North Sea oil revenues saw UK manufacturing output fall roughly 20%. British heavy engineering exports were priced out of European and Commonwealth markets almost overnight. Between 1979 and 1983, over 2 million British industrial jobs disappeared, 1.7 million of them in manufacturing. Lincoln was not exempt. The third decision, the one that severed the transatlantic lifeline, was the 1985 management buyout. In August, and the new owners, local management, experienced, committed, but desperately undercapitalized, faced the task of competing against Komatsu, Caterpillar, Hitachi, and JCB with a fraction of the resources and none of the global infrastructure. The same year, Bucyrus Erie independently acquired the Ransoms and Rapier walking dragline assets from Ipswich, consolidating the American side of big dragline design while cutting Lincoln loose from the heritage it had helped to build. The message was plain. South Milwaukee was keeping the intellectual property that mattered and discarding the factory that had manufactured it. The fourth decision was the Goldman Sachs leveraged buyout of Bucyrus Erie in 1988. This had nothing to do with Lincoln directly. By 1988, the Lincoln Works was legally independent, but it destroyed any possibility of the former American parent riding to the rescue. Engineered with Goldman, Sachs and Company holding 49% of the equity, the LBO loaded Bucyrus Erie with over $100 million in debt against just $16 million in equity. By 1989, the company was paying $21 million a year in interest alone. The financial model had assumed losses in 1990 to 91. When profits came in higher than expected, the mandatory debt service payments paradoxically increased, consuming the very cash flow that might have stabilized the business. The wreckage was extensive. Jackson National Life, holding $60 million face value of Bucyrus bonds, sued Goldman Sachs for alleged fraudulent misrepresentation of the company's financial health at issuance. Milbank Tweed partner John Gellin was jailed for undisclosed conflicts during Bucyrus's Chapter 11 reorganization, a case that became a standard law school study in legal ethics. Bucyrus Erie filed for bankruptcy protection on February 18, 1994 in the Eastern District of Wisconsin and emerged on December 14, 1994, stripped of debt but also stripped of a decade of development time. For the entire period of Lincoln's slow death, 1985 to 2001, the former American parent was absent as a source of capital, technology, or strategic support. It was saving itself. The fifth, and perhaps most poignant, was the absence of anyone to intervene. The Thatcher-era policy toolkit contained no clear mechanism for rescuing private heavy engineering firms. British Steel, British Coal, British shipbuilders were being privatised, not expanded. Trade union reforms, the Employment Acts of 1980 and 1982, the Trade Union Act of 1984 under Employment Secretary Norman Tebbit, had structurally weakened the industrial bargaining power that post-war Lincoln wages had rested on. The 1984-85 miners' strike, following Nicholas Ridley's pre-strategy leaked to The Economist in 1978, ended in NUM defeat on March 3, 1985. The collapse of British deep mine coal, from 174 deep mines in 1984 to 15, at privatisation in 1994 to 0 deep mines by December 2015, when Kellingley Colliery closed, destroyed RB's key domestic customer. Lincoln had no charismatic political champion equivalent to the Upper Clyde work-in. The Lincoln MP at the point of crisis, Gillian Merron, Labour member from 1997, inherited a factory that was already a fragment of itself. By the late 1990s, British industrial policy was an increasingly rhetorical exercise, and nobody in Westminster was going to save a works in Lincoln that employed 30 people. The independent RB did try. In 1987, the firm produced the 51-60, a mechanical hydraulic hybrid derived from the 38 RB. In 1989, it acquired Pegson crusher lines. In 1990, it acquired Priestman's variable counterbalance hydraulic long-reach excavator and grab ranges from the collapsed Sanderson Group, the Priestman name, from Hull, bought by Lincoln in a last attempt to build a credible hydraulic portfolio. In 1992, it introduced the CH series fully hydraulic crane draglines. A 1996 buy-in management buyout reset the ownership again. But the 1990s pound appreciation, the death of UK deep coal demand, and the relentless pressure of Japanese hydraulics at every price point made the arithmetic impossible. You cannot build a global excavator business from a 400-person factory in a market where your competitors have workforces of 40,000. Chapter 11. The Last Machine. On July 3, 2000, RB International entered voluntary administration. Richard Rees, a partner at PricewaterhouseCoopers, was appointed administrator. The cited reasons were a strong pound and overseas competition. The same forces that had been pressing on British heavy engineering for 20 years, expressed now in the formal language of insolvency law. The workforce at administration stood at 30 employees. 30, not 3,000, not 400. 30. A sale to Daniel E. Davis, former president of the Australian crane manufacturer Favel Favco, was negotiated during the autumn. It collapsed in due diligence in October 2000. The reasons were not publicly detailed. The effect was to leave RB International in PricewaterhouseCoopers' hands through the winter, trading under administration while Rees explored other options. During that period, the works completed a 50-ton crane for a UK customer, the order that, in Rees's words, allowed trading to continue. 30 people, in a factory built for 3,000, assembling one crane through the autumn and early winter of 2000. That 50-ton crane was effectively the last machine built at the Beaver Street Works. On 22 December 2000, Langley Holdings plc, run by Tony Langley from Nottinghamshire, acquired RB International as a going concern from PricewaterhouseCoopers. Langley had acquired Rolls-Royce's materials handling division the day before, forming the Clark Chapman Group, which also included Cowans Sheldon, Stothert and Pitt, and Wellman Booth, a collection of distinguished British heavy engineering names, each with its own history of decline, gathered under a single holding company. On 12 January 2001, the Lincoln head office and manufacturing facility at Beaver Street closed. Operations were consolidated to Clark Chapman's sites at Retford and Gainsborough. Most of the remaining 30 Lincoln employees were offered relocation. There were no protest marches, no occupation, no television cameras at the gates, no delegation to Parliament. The factory had wound down so far, so slowly, over so many years, that the actual moment of death registered mainly in the trade press, a paragraph in Contract Journal in July 2000, a notice in Cranes Today in January 2001. Lincoln had lost its giant so gradually that the final silence was almost private. A winter Friday, a handful of men clearing out their lockers, a gate that had opened for 70 years swinging shut for the last time. Chapter 12. What replaced the cathedral? The Beaver Street site was demolished in phases, each one erasing another layer of the works that had built the machines that dug the modern world. In the 1990s, even before the final closure, the machine moulding shop at the eastern end was cleared for a Morrison's supermarket, a petrol station, and a new roundabout at Centaur Road. Immediately after the 2001 shutdown, the eastern bays were demolished for a B&Q warehouse at the Beaver Street and Firth Road roundabout. Through the 2000s and 2010s, demolition worked westward, bay by bay, as if the site were being eaten from one end. The Ruston Research Centre, which Derek Broughton had called probably one of the best diesel engine test facilities in the world, in its 1950s heyday, came down around 2005. Thorngate House, the former Ruston and Hornsby headquarters opposite, was demolished in 2004 and replaced by residential flats. Today, the remaining cleared brownfield, approximately 19.5 acres, is marketed by Brown & Co. and Cushman and Wakefield for mixed-use redevelopment. Bays 17 to 20 are partially let to LC and M Limited. Full vacant possession is projected for April 2026. Adjacent retail parks, Tritton Retail Park on the former Ruston Boiler Works site, St. Mark's Retail Park, Valentine Retail Park, occupy much of the old engineering belt southwest of the city centre. Where the Noble and Lundplaner machined the side frames of 150-RB shovels, there is a car park. Where number 3 bay rose 80 feet to its roof trusses, there is a retail unit. Where the test ground cranes lifted 120 tons, there are trolleys. A frequent misconception is worth correcting. The University of Lincoln's Brayford Pool campus, opened in 1996 by Queen Elizabeth II, was built on former British rail land, the derelict Brayford Marshalling Yard, not on the Ruston-Bucyrus site. The RB Works sat approximately a mile further southwest, off Tritton Road. The university does incorporate restored Victorian railway buildings, the great central warehouse as its library, the engine shed as its students' union, but these are railway structures, not RB structures. The university's expansion has drifted toward the old engineering area, and the Beaver Street site is now described in commercial marketing as adjacent to the campus. But the connection is geographic neighbour, not built upon foundation. There is no major memorial at the Beaver Street site, no listed building, no plaque on the wall where number 1 bay stood. Ruston Way, the street name, and the wider Tritton Road nomenclature are the modest civic acknowledgements. A man's name on a road sign, readable at 30 miles an hour, commemorating a works that employed 3,000 people and built the largest excavators in the world. Lincoln didn't lose only Ruston-Bucyrus. It lost an entire engineering ecology within a single lifetime. Clayton and Shuttleworth at Stamp End, 1,700 employees in 1885, builders of over 500 Sopwith camels in the First World War, entered liquidation in October 1929. William Foster and Company at New Boltham, the birthplace of the tank, where the number 1 Lincoln machine first ran on September 9th, 1915, and where workers were told they were building water tanks for Mesopotamia to preserve secrecy, closed in 1968. Roby and Company at the Globe Works, builders of Sopwith triplanes in one war and frigate engines in the next, ceased trading in February 1988 after 134 years. Clayton de Wandre's closure in November 1986 alone cost 700 jobs. In Broughton's late 1950s peak, the engineering firms together, Ruston-Bucyrus, Ruston and Hornsby, Clayton de Wandre, Roby, Foster Gwynns, Smith Clayton Forge, and the smaller shops, employed something like 10,000 people in a city of about 75,000, a third of Lincoln's workforce. By 2000, only Ruston gas turbines, by then trading as Alstom, soon to become Siemens, survived as a major engineering operation. Every other big Victorian name was gone, but the Ruston name does survive, and the survival matters. Siemens Industrial Turbomachinery Limited remains the living continuity of the firm Joseph Ruston founded in 1857. The gas turbine business, launched in 1946 under Bob Fielden at the original Waterside South Works, renamed Ruston Gas Turbines in 1969, European Gas Turbines in 1989, Alstom Gas Turbines in 1998, Siemens in 2003, now employs around 800 people on the original Ruston site, which carries the address Ruston House, Waterside South. In 2012, Siemens opened the £4 million Joseph Ruston building, dedicated by the Bishop of Lincoln, a conscious act of corporate heritage in a city that had lost most of the firms whose heritage it might have honoured. The company has invested roughly £100 million in Lincoln since 2010, including a £6.5 million consolidation of R&D from Firth Road back to the main Ruston works in 2019 to 20. Lindham Joinery was commissioned to build 42 heritage-style timber windows for the Victorian building, a detail so careful, so respectful of the original fabric, that it amounts to a small act of industrial remembrance. The SGT 100, SGT 200, SGT 300, and SGT 400, industrial gas turbines rolling off Lincoln lines today, are direct descendants of the first 1 megawatt TA that Bob Fielden delivered to Kuwait Oil in 1952. The lineage is unbroken, the men and women making them work in a building that Joseph Ruston would recognise. Chapter 13. The Steam Navvy in the Blue Lagoon. The preserved machines are scattered and loved, and the story of how one of them survived is the piece of heritage gold this documentary should not leave untold. The Museum of Lincolnshire Life displays an RB4 from 1929 and a 17RB from 1937 in its yard. Modest machines, modestly presented, carrying the RB name into the public memory of a city that has otherwise moved on. The Vintage Excavator Trust at Threlkeld Quarry and Mining Museum in Cumbria holds approximately 80 machines, including the restored 110 RB electric face shovel and a working 38 RB. Beamish Open Air Museum in County Durham operates a 1931 25 RB, one of the last steam-powered shovels built, recovered from a Hessel chalk quarry, and an operational 1937 17 RB. Snibston Discovery Museum displays a 54 RB dragline from 1957. But the machine that matters most is Ruston, Proctor Steam Navvy number 306. It was built in 1909, the year Edward VII still sat on the throne, and the Sheaf Ironworks employed over 2,000 men. It was a rail-mounted steam excavator, a direct descendant of the Dunbar and Ruston machines that had dug the Manchester Ship Canal, the type of machine Joseph Ruston had demonstrated to the Institution of Mechanical Engineers while reading his newspaper. Number 306 was sent to the Arlesey Chalk Pit in Bedfordshire, where it worked for over 20 years, digging chalk for the cement industry. When the pit flooded in 1930, the machine was abandoned. The water rose. Number 306 sank. 25 feet below the surface of what locals came to call the Blue Lagoon, it sat in darkness for 47 years. In 1976, Ray Hooley, the Ruston and Hornsby librarian and archivist, a man whose job was to preserve the firm's documentary history, learned that divers from the Bedford Sub-Aqua Club had been exploring the flooded pit and had photographed a maker's plate on a submerged machine. Hooley identified it from the plate as Steam Navvy number 306. He understood immediately what it was, one of the oldest surviving Ruston excavators in existence, sitting in recoverable condition under 25 feet of chalk pit water. What followed took 18 months. The Bedford Sub-Aqua Club dived repeatedly to attach airbags and winches to the submerged machine. A local sailing club, whose members had been using the projecting jib of number 306 as a race marker, objected to the recovery, on the grounds that removing the machine would spoil their course. The objection was overruled. In October 1977, Steam Navvy number 306 broke the surface of the Blue Lagoon for the first time in 47 years. It was brought to Beaver Street, and here is the detail that gives the story its emotional weight. The machine was restored to working order between 1977 and 1980 by Ruston-Bucyrus apprentices. Young men in their first years of training, learning their trade on a machine built before their grandfathers were born. The training scheme repairing a steam navvy older than the joint venture itself. The continuity of skill, hand to hand, generation to generation, made physically real in the act of bringing a drowned machine back to life. After loans to the Museum of Lincolnshire Life, number 306 was transferred in 2008 to the Vintage Excavator Trust at Threlkeld. A £40,000 Heritage Lottery Fund grant financed a full restoration, and by 2015 it was back in steam, working, moving earth, doing what it had been built to do in 1909. It is now described as the world's oldest working excavator. On February 28, 2023, at the age of 95, Ray Hooley received the National Transport Trust's Lifetime Achievement Award at Lincoln Guildhall. The documentary, The Ruston in the Blue Lagoon, produced by Blow Productions in 2020 to 21, tells the full story of the recovery. But the moment that matters for this documentary is simpler than any film can show. A man who spent his career preserving the memory of a firm, identifying a drowned machine from a diver's photograph, and setting in motion a rescue that would produce the single most powerful symbol of what Lincoln's engineering tradition was, and what survived when everything else was lost. Chapter 14. The Inheritor. The final chapter of the Ruston-Bucyrus story belongs to an American boardroom in Peoria, Illinois, and to an irony so layered it almost defies narration. Bucyrus Erie emerged from its 1994 bankruptcy under Willard W.R. Hildebrand, who became CEO in March 1996. The company renamed itself Bucyrus International in 1997 and, in a move that ended a 113-year rivalry, acquired Marion Power Shovel from Global Industrial Technologies for $40.1 million. Timothy W. Sullivan, who had first joined Bucyrus in 1976, when the Lincoln Works still employed thousands, was appointed president and CEO in January 2000. Sullivan's turnaround was remarkable. Between 2000 and 2010, Bucyrus revenues grew from $280 million to $3.65 billion. Employment grew from 1,700 to 11,800. In December 2006, Bucyrus acquired DBT GmbH, Deutsche Bergbautechnik, the Lunen-based underground coal equipment group, for approximately $731 million. In February 2010, it acquired the mining equipment division of Terex for about $1.3 billion, inheriting the former O&K hydraulic line, including the RH400, the world's largest hydraulic excavator. Then, on November 15, 2010, Caterpillar CEO Doug Oberhelman announced that Caterpillar would acquire Bucyrus International for $92 per share, $7.6 billion in equity value, $8.6 billion including net debt, the largest acquisition in Caterpillar's history. The deal cleared Department of Justice antitrust review in May 2011 and closed on July 8, 2011. Caterpillar established its new global mining headquarters at the former Bucyrus site in South Milwaukee. Production continued there under Cat branding until 2016, 123 consecutive years of manufacturing from the 1893 Milwaukee move to the 2016 closure. Sullivan retired. He is now, from 2023, Dean of the Sullivan School of Business at Carroll University. The ironies require no editorial. They speak for themselves. Caterpillar was the company whose foundational crawler technology came from the Hornsby chain track patent sold from Grantham in 1913. It was the company that had shipped the hydraulic model 225 in 1972, while Lincoln was still building cable machines. It had spent 4 decades eating the market that Ruston-Bucyrus refused to adapt to, and in 2011, for $8.6 billion, it bought the cable and rope heritage wholesale. The hydraulic pioneer absorbed the rope shovel champion. Goldman Sachs, the firm that had nearly destroyed Bucyrus with its 1988 leveraged buyout, that had loaded the company with $100 million in debt against $16 million in equity, that had helped trigger the 1994 bankruptcy, underwrote the 2004 IPO when Bucyrus returned to public markets. Goldman profited. It served as advisor on the 2011 Caterpillar acquisition. Goldman profited again. In South Milwaukee, on the site of the old Bucyrus Works, now Caterpillar's global mining headquarters, the Cat 6090 hydraulic shovel rolls out for customers in Chilean copper mines and Australian iron ore pits. It is a direct descendant of the O&K RH400 that Bucyrus inherited from Terex. It is a hydraulic machine. Its grandparents were cable. The lineage, at last, is continuous, from a Chatteris fen boy with a cutlery apprenticeship to a Peoria boardroom, via 71 Manchester ship canal navvies, 1,600 Sopwith camels, a Churchill trench digger that never saw combat, and a bridge over Lincoln's High Street that used to carry a sign the world believed. Chapter 15. What the Silence Keeps. In South Milwaukee, excavators still roll off the line. In Lincoln, the gas turbines still turn. At Threlkeld, steam navvy. Number 306 works under steam on Heritage Days, the boiler pressure rising, the buckets swinging, the sound of a 19th century machine doing what it was built to do in a 21st century quarry. Almost every thread of what Lincoln made is still at work somewhere in the world in 2026, under other names. The crawler track that Hornsby patented in 1908 and sold to Holt in 1913 is under every Caterpillar machine on every construction site on Earth. The walking dragline designs that Lincoln built under Bucyrus license are still operating in coalfields from Wyoming to New South Wales. The gas turbine line that Bob Fielden started in 1946, on Frank Whittle's encouragement, powers oil platforms, pipeline compressor stations, and industrial plants from the North Sea to the Persian Gulf. And it still carries, in its corporate address, the name Ruston House. The firm whose apprentices restored a 1909 steam shovel from a flooded chalk pit is itself now a heritage entry in someone else's corporate history. Ruston-Bucyrus appears in Caterpillar's ancestry chart. It appears in Siemens's corporate genealogy. It appears in the records of the Vintage Excavator Trust and the catalogues of the Museum of Lincolnshire Life. It does not appear on the Beaver Street site, where the bay numbers have been replaced by retail signage and the test ground has become a car park. Walk down Beaver Street now and what you'll find is the particular silence of a place built for noise. The ground that shook with the rhythm of 16-cylinder Rustons at full power is still. The air that smelled of coolant and welding arc and diesel fuel and heavy fuel oil, the air that clung to overalls and announced to anyone on the bus that you worked at RB, smells of nothing in particular. The 80-foot roof of number 3 Bay is gone. The Noble and Lund planer is gone. Bob and Beano are gone. The sign over the high street is gone. What remains is a 1909 steam navvy working under its own power in a Cumbrian quarry. A gas turbine works on Waterside South with heritage windows and a building named for the founder. And the memory, carried in the accounts of Derek Broughton and Taffy and Ray Hooley, and the unnamed thousands who walked through those gates across 7 decades, of a factory that built the machines that dug the modern world. Not through one catastrophe, through a cable bet held too long, 2 parent companies pulling in opposite directions, a leveraged buyout that consumed a decade, and a town that lost its purpose so slowly that the moment it ended was almost silent. A winter Friday, a gate swinging shut, and a works siren, somewhere in the Lincoln Central Library's oral history archive, that sounded the shifts for 70 years and then went quiet. The last voice of a city that built colossi and watched them walk away.